unmuting yourself. So wala na. Everyone got it. Did everyone get all of the screenshots? Pa-scroll again, sir. Sige, which one? Mr. Tan, which one? So sa start, sige. So only page 1. This is page 1. This is page 2. This is page 2. This is page 3. This is page 4. This is page 5. This is page 6. This is just the last page, okay? So hopefully you got everything, no? So that we can move on to the actual discussion. So I'm now showing you my PowerPoint. So before I proceed, let me just ask you, maybe some of you can answer this. Where are you now in your lecture class? So what was your discussion in your last lecture class in this fundamental to EE subject? Hello? So asa na mo dapita, guys?
I think nakatakol to mig resistance, sir.
Okay, so napa mo sa resistance? Any particular topic in the resistance? Like, wala ko i-elect, sir. Okay. How about to those people na na-lecture? Asa na mo dapita, guys? So you can unmute yourself and maybe. Okay, so naapa mo sa electrical terminologies. Okay, so medyo layo-layo na gid no sa ato experiment number 4. So sige lang. Not necessarily yun na siya always in parallel. So sige lang, hopefully we can finish up, or your lecture class can catch up to the laboratory, no? For a while. Okay, so I'm back now. In the previous lecture class, or the previous experiment, what we have tackled is, again, your Thevenin's equivalent circuit. So shown here is any kind of two-terminal network or two-terminal circuit that is linear and has two terminals going to some output. Okay. So in this particular context, your load or the output will be fed to some load, may it be a resistor or sometimes even an impedance. So if this is AC, now we have theorized that this actual network can be replaced by an equivalent network, which is simply a voltage source VTH connected in series with some resistor RTH or some equivalent resistor RTH. So these two circuits are basically equal. No? In a way, this is just one of the kinds of simplifications that we can make, no? In order for us to what they call this, to better analyze a complex system. Okay, because it's not always that the components here or the actual circuit here, it's not very it's very time consuming if you were to resort in regular network analysis, no, given the circuit. So why not just represent this by an equivalent circuit, which is your Thevenin. So this is one of the equivalent circuit. And for the next one, which is also our topic for this lecture, is your Norton's equivalent circuit. So your Norton's equivalent circuit, it's a parallel circuit instead, having some short circuit current I of N being shunted to some Norton equivalent resistance Rn. Okay, and then this has to, of course, the two nodes here are attached to your terminals of interest, which is your terminals A and B in this context. Okay, so there are actually similarities from your Thevenins to your Norton's equivalent circuit. So your RTH is actually equivalent to your Rn. So this is your this is the equivalence between the two. So there's actually a much deeper circuit theorem here, in which hopefully we can tackle that later on. But this is just basically the source transformation between the two. So again, they have the same RTH or Rn or equivalent resistance, but their driving source is different. So the very obvious difference, firstly, is of course your Thevenin is your open circuit voltage. So this is the voltage across your terminals of interest. So across A and B, when there is no current flowing through this portion of your circuit, when I is equals to 0. Again, when we say open circuit, the current that is flowing through your terminals is essentially equal to 0. So instead of an open circuit, your Norton's equivalent circuit would be a short circuit instead. So these two lines, we simply short this out by a zero impedance path, and the I, or the current that is flowing towards your positive terminal, which in this case that would be your A. So we're just taking into consideration the norm. So we solve for I of N when there is a shorted line from B to A. Okay, so let me demonstrate that through the actual diagram that we'll be using. So this is your V1 connected in series R1, shunted across your load is your R2, and you also have your terminals of interest. So this is your A and this is your B. And normally we connect our R3 here, which is our load, diba? So our R3 is our load. No? So right now, let's just remove that for simplicity. So we attach a series resistor here. So this is R3, or no, this is R4. And you have V2 here. So again, much like what we did in the previous example or in the previous experiment, when you would try to solve for your RTH or your Rn in this case, so you simply disable the voltage sources. Okay, so you disable the voltage source and then apply a short circuit between its terminals, and then solve for the equivalent resistor across A and B. Now in the experiment, again, what we can do is that we can excite this circuit with some voltage source having a fixed value 1 volt, and then just take the reciprocal, or no, measure the current and then take the reciprocal for the equivalent resistance. So that's how we solve for that. So how about your IN, or the short circuit current? So we connect the, what do you call this, the voltage sources here. So this is V1 and this is V2. And again, when we say IN, or when we say short circuit current, we simply apply we simply connect these two terminals here. We short this out, okay? And then you solve for the current IN going above. So now, to solve for this, maybe I can use nodal analysis. So hopefully, maybe I can share with you my playlist for the lecture class, so that just for additional viewing lang, so that we can proceed to more advanced experiments in our manuals, no? So if this will be our nodal, if we were to apply nodal analysis, again, you apply some ground node. So this is your 0 volt. And then you solve for your I of n, or your short circuit current. So do take note that when you apply the ground here, so everything else, all of this points, so this one that is being highlighted by yellow, this is all a zero potential point, no? So when you're doing your KCL analysis, you can do your KCL analysis over this node, okay? So how do you solve for IN in LT-SPICE? So you can't actually measure the short circuit current in LT-SPICE, okay? But we can approximate, no? So instead of just putting a shorted line here, we can actually just place a resistance, no? Okay? So you place a resistance, and in this resistance, you can set its value as 0.000001, okay, ohms. So you set the value of the resistor in such a way that its its resistance is almost negligible, okay, and then you and then you measure the current that is flowing upward, no? So this is your I of n, okay. So that's what you will be doing for this particular experiment. So are there any questions, guys? So mata pa mo. Are there any questions regarding the topic? Questions? Any kind of questions, no? So wala ko, sir. So si Elaine, humana magkagkuan, humana kag ka nang i-elect, Elaine? So but wala pa ka na human? Wala pa. Okay, so pwede ka mag-unmute sa imong self, no, if ganahan ka matubag. But anyways, other questions, guys? Maybe Rex or Sophia. Si Sophia, naki-question?
Sir, ang sa Thevenin, sir ba, can we do the same with that, sir nga? Imbes short kay ang butangan gihapon resistance, sir, or sa Norton's run na siya, sir?
Sa Thevenin's kay no. Kay ang Thevenin's man good, pwede man mo siya directly ma-measure ang iyang voltage good. Kay if for example, no, so sa case sa Thevenin, if i-erase ni nato siya, okay? So take note mo ni siya atong ground, di ba? Kanang sa bottom na portion, no? So ato magi-attach nga natong ground if ever katong sa experiment ba. So ang VTH nimo is your voltage across these two terminals, di ba? VTH. So another interpretation of voltage man good, if you would take a look at node voltages, so pwede ra nimo kwaon ang difference sa voltage nga ni sa taas o nga ni sa ubos, sa top o sa bottom, okay, para makuha nimong VTH. Now when we do that, kay kuan man siya kanang in LT-SPICE, di ba, naramang kay kuan, naman kay katong imo ang probe, di ba? So take note, ang probe nimo sa imong LT spice, when you attach that anywhere in the circuit or any node in the circuit, ang gi-measure gyud na voltage is with respect to your ground. So meaning if nanira nimo gi-attach imong kuan, imuhang kanang probe, ang na-measure nimo na voltage directly is already VTH. Okay? So pwede direction
Okay,
ra
sir.
siya. Yeah, okay.
Okay, sir.
Any other questions, guys? So wala ra no. Kanina lang siya. So since inyo ang kuan, inyo ang i-elect is medyo layo-layo pa man mo. So next meeting, dili lang sa ta mag-meet. Okay? But what I would like you to do is that I have prepared some video lectures, no? Video lectures for our EE circuit class or for my lecture classes, and then maybe I can share that to you so that you can maybe you can view lectures 1 to 3. So actually this is 1 to 3 dali ra siya paminawon or gamay ra siya paminawon, but actually napa ni siya 1A, 1B and so on. So taas-taas ni siya. So I would be expecting you to finish this. I think the viewing hours in total here is approximately 7 hours. So I know it's a lot, no, but trust me, it will be worth it. And don't worry, I will be extending the deadline for this experiment. No? So ani na lang, how about this one? I would like to request to you to watch lectures 1 to 3. Okay, so again, that's 7 hours so approximately. And I will just be extending your deadline for this particular experiment next week, Thursday. And then next week, Thursday as well is mausa na siya to ang midterm exam. Okay? And our midterm exam is kuan lang ta guys, I think we will just do computations, no? Because if I were to have some kind of practical exercise, again, not everyone has the laptops or the desktop at their disposal. So a work around that is that maybe we can just have a purely written exam for this laboratory class. So would that be okay? Would that be okay, guys? I will give you a sort of assignment. No, again, view lectures 1 to 3, and then hopefully by next meeting we can, or by next Thursday you can submit your experiment, and then we can do your midterm examination. Would that be okay, guys?
Pwede i-extend pa jud ang deadline sa lab, sir, sa experiment para anang time frame kay maka-focus mi sa pag-catch up sa mga lessons. Kay if ever magud kanang mura japon gadoble ra japon ang cancer ba among buhaton. Kay magdungan man ang duha ka buok.
Sige, so ang ganahan ninyo is Tuesday next week, so that's 22. So sige, pwede ra pod kuanta, pwede ta September 22 ang deadline sa experiment, and then from this day up until Thursday kay inyo ang istudihan is kanilang. So okay ra mo ana? Pwede ra sad ko ana. Ato ang midterm is kuan lang atong midterm, dali ra, kuan ra siya. Thevenin or Norton, nara nang duha. Niyahan calculation. So, is that acceptable, Mr. Charles? So, sige, ang deadline sa experiment number 3, number 4 is September 22. And then September 22, sad mag-discuss na tagbago na topic. Hopefully, we can go over to AC already. So, September 22, and then Thursday, for this Thursday, September 10, and then for next Tuesday, which is September 15, you will just be studying everything in this lecture, no, from 1 to 3 lang. Okay? So again, this would require you at least siguro 7 hours. I know it's a lot, but I think the content is really, or for you to actually move on to AC circuits, it's actually good that you grasp the lessons in the content, no, or in this lecture. So sige, okay ra mana. Kinsay dili okay ana, kinsay ganahan mag-exam diretso next week kay mo dive. Sample problems. Yeah, I think nara na siya sa lecture ang mga sample problems. Why siguro gani if kapuyon ko kay pwede ra gani naa nga to sa sa lecture daan ang exam, mura siya ba? Kana ganing kabaw mo ng tripping sa mga karaan na instructor sa una. Kana maluoy na ba? Exam poll. Nya ang pagsuwat ana niya sa blackboard kay nani. Exam poll. So ini ka discussion ba, so kana na may clue, no? So possible inana, possible basta inyo lang gitanaw ang lecture. So okay ra mo na or basin mas ganahan mo kuan, sige lang dilang tanawon lang, no, but possible na ang exam nara nga to nara sa lectures 1 to 3. Okay, alipay ang Elaine, eh. Lipay kay Elaine.
So, sir, clarify,
Yeah.
sir. Ang
Okay.
2 ug 3 ipas karong September 10.
Yeah,
Yeah, ang 4 ang katong ig 22.
yes.
Okay, sir.
Ang
Thank you.
wala na change ang deadline sa 2 ug 3, but ang sa kuan sa experiment 4 lang. Or unsa man dili gyapon mahuman inyong 2 ug 3 karong kuan this coming what do you call this? This coming Thursday?
Oh, sir, kay
Oh, sir.
Sige ana, kani guys, okay ra ko na experiment 2 and 3 kay isubmit sa dinyo 22, pero big pero, no, pero INC mo midterms. Ang INC man sad good, ay kabalaka na, no, when I say INC, don't be scared, no. Ang INC is ko na siya kanang dili na siya mogawas sa inyong transcripts na INC mo sa midterm. Okay, in fact dili na mogawas gani if nahagbong mo sa midterm, but INC lang kamo kay wala pa na complete inyong experiment. Okay ra na siya. But don't worry, wala mo nahagbong na. Okay, you have my word that no one will fail this class. Okay? Ang ako lang is para makaapas inyong lecture. Okay ra mo ana. So timan niya dili if na INC mo midterm, dili na siya mogawas sa inyong transcripts. Okay? Wagi na siya problema, di na siya mogawas sa inyong transcripts. Kaya na ako student sa una na marging na nakuha na niya. Pag ingon na okay, kay lakon kay siya, no, kay although nagito siya issue marsag na sakit, then absent siya niya ni kay lakon siya niya ako siya gihatag kuan na dili gyud na siya mogawas ang INC sa inyong kuan sa inyong kanang transcripts. Okay? Basta kuan lang ini ka ang matter na di ka finals na, no. So okay ra mo ana. Basinay kuan niya ba? Basinay kanang grades is life ba niya? Di gid mo dawat na walay grade ka midterm. So okay ra mo ana. Sige ha. Okay. So final na. Midterms is INC lang sa tanan, and ang deadline sa 2, 3 and 4 is September 22. Okay? Then our midterm is September 17, Thursday next week. So is that acceptable to everyone? So okay ra, no? Sige. Okay, any other questions, guys? Ako lang i-send ang link sa kuana sa ato ang group, no? So any questions? Other questions?